Okay, so draw yourself a normal distribution. First of all, you ask yourself, what is the mean of the original data? That is the same as the mean of the central limit theorem. So that mean is 73, and you're told to accumulate to the right of 79.4, and 79.4 is at the right of 73. And remember, accumulating to the right means area to the right. We have already found the standard error. The standard error of, so we can now plug into, you can use your calculator. Anywhere you can use your calculator in your final exam, please do use your calculator. Okay, so before I continue, I just want to let you know that attendance to classes this week are optional. I will mark you present if you are in face-to-face class. Just do your exam. The important thing is that you completed your final exam, because final exam will replace a low test grade. If you cannot do test number 4, well, that's fine, provided you do well in final exam. Okay, so I will do normal CDF, lower bound. Remember, that's the argument. Lower bound, upper bound, the mean of the sampling distribution, and the standard error. And I already have standard error here. I have everything I need. So I will quickly substitute in this information. So remember, we found the standard error right here. So we know that standard error is right here. So I'm going to clean this part. All right, so now I will substitute, get my calculator and do it. So normal CDF. I already know that lower bound is 79.4 because I'm accumulating to the right. Remember, it is area to the right. My calculator does not understand infinity. So that the infinity to the right is positive infinity, 1e to power 99. The mean of the central limit theorem is the same as the mean of the original data that is skewed, and the standard error, not standard deviation. This is why I'm reviewing this, because people might have forgotten. Remember, you have to use standard error whenever you are told to find the probability of X bar. Whenever you're finding the area of X bar, it means it's a central limit theorem. So we found the standard error to be 4, not 24. If you can do that, that's a whole lot of the problem. Now plug it into your calculator. So I'm going to pull my calculator up. I can make it bigger. It's too small. Okay. We'll turn my calculator on. And then remember where to go to do normal distribution. Second distribution, normal CDF. So it is normal CDF. I'll select number 2. The lower bound is 79.4. So 79.4. The upper bound is infinity. Remember, just remember, to type in infinity, you put 1 right there. Then remember that the E is under comma. So second E to power 99, that's infinity, positive infinity. This is not a standard normal curve. So I'm using a raw data. Because I'm using a raw data, I have to put the mean. The mean of the sampling distribution is 73. The standard error, remember, the standard error, people always forget. Okay, and then I will paste, and my calculator is asking me, is that the argument you want? I say yes. That is the argument I want. Therefore, the probability that the mean is, that mean there is greater than 79.4 is 5.48%. If I'm told to leave my answer in decimal, okay, let me see. Let me see if my answer is, I want to see the number of decimals. I don't even think they told me the number of decimals. So I can just put my answer either in decimal. So remember that you have to describe the sampling distribution. The description will say, the central limit theorem says that whether the original distribution is skewed left or skewed right or normal, the distribution of means will be approximately normal, which means you will not say there is not enough information. No, there is enough information in this data because according to central limit theorem, it can be skewed right, skewed left, or from normal distribution. Okay, so my answer in decimal can be I hope everybody's seeing it, 0.0548 or 5.48%. You can leave it any way you like. Okay, I will, the same way you will do C. And I will just do D again, just to make sure that, by the way, do you have any question? Including those online, if you have a question, you unmute yourself. Those of you online, if you have a question, you can unmute yourself and ask a question or type it in chat. Type a question in chat. I just did A and B of number 1. I hope you know that that question is already in the final exam. Yes. How did I get the probability? Oh, this question means, what is the probability? That's what it means. What is P? That's the probability that the random variable X bar is greater than 79.4. Okay. Okay, so I'll go back and do it again because somebody needs, please, if you need me to repeat anything, let me know. So first of all, I will write the formula because if the person wants to see that I know the argument, you put the argument up right here. The argument is normal CDF, lower bound, upper bound, mu X bar, the mean of the original distribution, and the standard error. But first of all, you calculate the standard error. Standard error is the standard deviation of the original data divided by square root of sample size. And we already did calculate the standard error, and it is 4. So right here, I plugged in all the numbers that I already know. So the lower bound is 79.4. The upper bound is 1 e to the power 99 because it is positive infinity. I am accumulating to positive infinity. I hope you remember this. And then the mean of the original data is 73. Therefore, the mean of the central limit theorem is 73. And the standard error is 4. Remember that central limit theorem is the same as the distribution of means, right? Remember, okay. So they could say distribution of means, it still means central limit theorem. Okay, so when you put it there, you go to, maybe this is what you did not understand. Okay. I told you that's the problem. People always put 24 in place of standard error. No, that is the biggest problem. You cannot put 24, which is the standard deviation, because this is central limit theorem. Well, guess what? This is why I'm doing this number. That is why, because this is the mostly failed question in every Unit 4 test and in every final exam. This is the mostly failed question because people forget that this is talking about central limit theorem. Okay, let me go back again and do it. So second distribution, the same thing as normal distribution. So I'm going to select 2. And then the lower bound, as we know, is 79.4. The upper bound is positive infinity. And the mean of the population is 73. Therefore, mu X bar is 73 also. And then the standard error. You know, calculator did not tell you standard error. So you should know, you are the one operating the calculator. you should know to put a standard error right there. Okay. And then you paste. So I'm going to paste. And then I hit enter. Then depending on the number of decimal points, we put the answer in decimal points. Remember, it's probability. So your answer cannot be up to 1. If it's probability, what one of the laws of probability says the sum of all the probabilities cannot be more than 1. It has to be 1. So that area is not up to 1. Okay. So we did number 1A. I would like to do 1B also. 1D. I already told you that this is the mostly failed question in final exam. That is why actually it's number 1. That's why I have to do it. Make sure that you're not among those who will skip it. I want to tell you that it's already in the test. It's in final exam. Okay, so let's do 1D. Well, this is area between in central limit theorem. Area between in distribution of means. Okay, well, let's see what is common. So the mean of the original data is 73, still 73, and therefore the mean of the central limit theorem is 73. The standard deviation is 24. Therefore, the standard error is the same as standard error of the first one, so square root of 36. And we see 24 divided by 6 is still 4. Okay, so we still have a standard error is 4, and then we fill in the gap. Don't forget to draw a normal curve. Forget to draw a normal curve, even though this is not a pen and pencil test. Then remember that this is area between, so you carve out the area between, and the area between is right here. The center is the mean, mu x bar, and that is 73. The lower bound is 68.4, 68.4. The upper bound is 83. Now, remember the argument. The argument is normal CDF, lower bound, upper bound, mu x bar, even though it's the same as the mean, standard error. Standard error. I can't say this enough. If you use standard deviation in place of standard error, your answer will be wrong. Okay, now I am going to fit in all that I know. I know that the lower bound is 68.4. We are doing 1D. So this is normal CDF. And then lower bound is 68.4. Upper bound is 83. The mu x bar is 73, the same as the mean of the original data that is skewed. And the standard error is still 4. So you go back to your calculator. So let's go back to our calculator and make sure that we know how to calculate this. So now second distribution, number 2. And then the lower bound this time is 68.4. So 68.4. The upper bound is 83. So 83. The mean is still the mean, and the standard error is still the standard error. So we are going to paste. My calculator is asking me, are you sure that this is what you want? Yes, that's what I want. And then remember it is area. Just in case you finish and get a negative, your area cannot be negative, and the area cannot be more than 1. So the area between 68.4 and 83 is In percent, 86.87%. In decimal, maybe 4. They can ask you to leave your answer to 4 decimal points. You have 0.8687. Any question? Any question? We need to get to another question. Any question? Those of you in class? Those of you online, if you have a question, you can type it in chat or you can actually unmute yourself and ask a question. Okay. Even if you are in online, you can still ask a question because this is a combined class. Okay, and attendance is optional, like I said, which means those of you who are not able to come, I don't mark people absent the last week of exam. So if you take your exam, you're marked present. If you don't take your exam, you actually already know what's going to happen because the exam is a standalone grade. It's a standalone grade, so you must make sure. Okay, so you feed in the answers you have. You feed in all the answers you have right here. Okay, well, there are some easy questions that I will not get to look at number. What are the 2 requirements for a discrete probability distribution? Okay, in a discrete probability distribution, the mean cannot be, the probability of a number cannot be less than 0. So we're going to start from here. Okay, so this is right. The sum of all the probabilities must be 1. Okay, so that's not a big problem. Let's get to permutation and combination. I just have to do 1. Remember, you can put them in your calculator, so it's not a big deal. But just in case you have forgotten, let's go to permutation. Okay, and if I am told to find 8 permutation 8, you don't have to write the formula because, oh well, let me write the formula. So suppose I'm told to find 8 permutation 8. Remember, it's the same as 8 factorial all over 8 minus 8 factorial. And end up having 8 factorial divided by 0 factorial. And remember that 0 factorial is 1. Somebody's going to say undefined here. The person was not in class. 0 factorial is 1, so your answer becomes 8 factorial. So you still have to go to your calculator and find 8 factorial, unless you want to multiply it out. Whatever you can do with your calculator, that is good. So I can just put 8 factorial here, 8, go to math, arrow to PRB, and number 4 is 8 factorial. Number 4 is factorial. So this is my answer, 40,320. Well, suppose I just want to put in 8 permutation 8. So I have 8 here, go to math, PRB, and permutation is number 2. So 8 permutation 8. I just want to compare my 2 answers. So it doesn't really matter if you cancel it out, you get the same answer. Any question? This is just a reminder. We already know this. I know you can do number 4. There are 20 questions here. I want to get to some most questions. Don't have to do all of them. All right. Okay, so a survey of, look at number 5. This is a proportion question. And remember that in proportion, p hat is the point estimate. In proportion, p hat is the point estimate. And remember that p hat is the same as the number of random variables over sample size or sample space. Okay, so a survey of this number of adults in a certain large country aged 18 and older conducted a reputable polling organization conducted. So a reputable polling organization found that 423 have donated blood in the past 2 years. So the most important thing here is The number who donated blood is 423 out of how many? 2, 3, 1, 6. So the point estimate is the number who donated blood over the point estimate. Okay, so that's what you're looking for. And you're told to round your answer to 3 decimal places. So point estimate, remember, is a probability. So it cannot be more than 1. So get your calculator and find the point estimate. Get your calculator. Okay, so the point estimate right there is number of random variables for 23 divided by the sample space or the number of people who were polled. 23, 16, and I'm told to leave my answer to 4 decimal places. Well, actually 3 decimal places. So my answer is 0.183. The point estimate is 0.183. Okay. Now, since my answer is 0.183, okay, verify that the requirements for constructing a confidence interval about P are satisfied. Okay, so the requirement number one is the sample size must be less than 5% of the population. 5% of the population. That's requirement number 1. Population is capital N. And number 2, NPQ, the variance must be greater than 10. So greater than or equal to 10. Okay, let's check that out. They did not give me the population. So anytime you're not given the population, you assume that is the population of the whole adults in America. So let's assume that this is America. The whole America is 360-something million. So imagine that all adults are 300 million, or let's say 200 million. Okay, we are just assuming. Well, guess what? 2316 is less than 200 million. So condition number 1 is satisfied. Condition number 1 is satisfied. It's from the sample size is less than 5% of population. Condition number 2 is that the variance must be greater than or equal to 10. So let me calculate the variance of the data. So sample size, N, sample size is 2316. The P hat is something as a point estimate is 0.183, and then Q hat, P hat plus Q hat must be equal to 1. Okay, so I'm going to say Q hat is going to be 1 minus P hat. So I have 0.183. Let me use P hat and Q hat here. Okay. All right. So I can get my calculator quickly and fit in what I have there. And when I find that out, I have found the variance of the data. And if the variance is greater than 10, I'm allowed to do inference. So let's figure that out. Condition number 2. All right. So 2316, 2316 multiplied by, so I'm going to multiply that by the point estimate, which is 0.183. That's 0.183. Then multiplied by, I'm going to use parentheses here, 1 minus, which is the Q hat. 1 minus 0.183, 0.183 close parenthesis. When I hit enter, I think someone was okay. So let's see, admit. Okay, I got it. Okay, so I have calculated the variance, one of the conditions, and the variance is greater than 10. Variance is 346 point something, so it's greater than 10. So the two conditions are satisfied. The variance is greater than 10, sample size is less than 5% of population. So I am allowed to do inference in this proportion, so I should do inference. Condition number 1 is satisfied. Condition number 2 is satisfied. So you can construct and interpret a 90% confidence interval. So let's go ahead and construct a 90% confidence interval, okay, of the population proportion of adults in the country who have donated blood in the past 2 years. Select the correct answer. So I'm going to get my calculator and quickly do the confidence interval. So I pull my calculator up. And remember where to go when you are doing confidence interval. Go to STAT and go to test. And by the way, I need to ask myself, what kind of confidence interval am I doing? Remember, it is proportion confidence interval. And the proportion we have satisfies the two conditions. It is binomial though. It is binomial and they satisfy the conditions for converting a binomial to normal. Those are the conditions we talked about. Therefore, I can do one prop Z interval. So one prop Z interval, not one prop Z test. So I'm going to be looking for one prop Z interval. And one prop Z interval is A. So I'm going to select that. And it's asking me, what is the number of people who donated blood? The number of people who donated blood was 423. 423. What is the number of people who were polled? 2316. 2316 were polled. What is the level of confidence you're given? 90.9. So I'm going to put 0.9 there. And I'm going to calculate the 90% confidence interval for proportion. Okay, so I have, I usually take a picture of this. So I'm going to take a picture of my, because if I touch the thing, okay, I'm just going to take a picture so that when it runs away, I have a picture. Okay, so now I want to write the confidence interval. Okay, so the confidence interval that I have, remember it is a proportion confidence interval, and I want to make sure, okay, so select the correct, then I will say, I'm not going to choose the answer for you here, but you should be able to choose the answer. You cannot be more confident than the confidence level given to you. So it must be, I am 90% confident, okay? And then I will quickly write the interval here. It is 0.169. This is the lower bound. Let me use a number line. That can help a lot. Okay, so this is the lower bound. The upper bound is 196. 196. And I'm also given the point estimate, which is p hat. So p hat is 183.183. And then I could be told to find the margin of error. It may not be in this question, but guess what? There is a question that will ask you to find the margin of error. The margin of error, ME, is upper bound. There are so many ways you can find it, by the way. Upper bound minus lower bound divided by 2. Actually, remember the margin of error is this distance or this distance. They are equal. We consider P to be the midpoint of the line segment. Okay, and then finding the margin of error, you find the lower bound, upper bound minus lower bound divided by 2. So these are the kind of questions you can have here. So now you make a conclusion. Therefore, I am 90% confident that the number of people who, or the mean of those who donated blood in this country, whatever country it is, USA, who donates blood here, the mean lies between 169.169 and 196. In other words, we don't know where the mean, or okay, let's say the population proportion. The population proportion, because if I say mean, it's just the population proportion of those who donate blood in USA lies between 16.9 and 19.6%. That is the population. Remember, in my 90% confidence. So I can say I am 90% confident. And remember, when you get the margin of error, for example, suppose you find the margin of error. Let's find it quickly. Let's find the margin of error quickly. So I have 0.196 minus lower bound, and the lower bound is 0.169. And I get an answer, and I divide the answer by 2. And I have 0.0135, or I can say 0.014 approximately. So the margin of error, this is another way you can write your proportion. So the population proportion is equal to sample proportion, which is the p hat, plus or minus margin of error. Margin of error. Okay, and we already know that margin of error is let me get my calculator again, 0.014. Okay, so you could just rewrite it as the estimated population proportion is equal to the sample proportion, or the point estimate 183 plus or minus the margin of error. And the margin of error is 0.014. So you are 90% confident that the population proportion can lie in this range. I hope you know that this and any other way you write it, they are the same. Is there any question so far? Any question? There are 14 of you. Those who could wake up. 8 a.m. class, it's not easy, so I can understand. Okay, I know that you know what complement rule is. So I don't think that this question will be a problem. Number 6. Number 6 will not be a problem. Does anybody want me to do number 6? Remember that if I'm told to find E complement, find the E complement, or anytime I'm told to find the probability of E complement. First of all, okay, let's look at that. Let's look at it. Wherever we don't have time, we stop. Okay, the probability experiment is conducted in which the sample space is the quantity right here. Okay, the quantity right here. And E is that. Assume each outcome is equally likely, list the outcome of E complement. In other words, find those who don't. First of all, I'll get E first of all. I want to get E complement before I get to probability. They are two different things. So I will go here. 12 is in E, so I'll take that out. 13 is in E, and 14 is in E. Okay, by the way, what is the sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So sample space is 12. And then E, I'll just say E has only 3. I can say N, E. Okay, and sample space And then I want to find the probability of, so now the probability of E, even though that's not what I'm told to find, probability of E is equal to 3/12 or 1/4. Then PE complement. So PE complement is 1 minus 1/4, which is the same as 3/4. Okay, so the PE complement is, so remember that if you're told to find the PE, probability of E complement is equal to 1 minus PE. The probability of E complement is 1 minus probability of E. And that's what we just did here. Okay, and my answer is going to be 3. First of all, you list all of them here. 9, everything that is not in E. 10, you got to list because you're told to list. You are told to list it. This means list all the E complement, which means list everything in the universal set that does not contain E. So you got to list it and omitting 12, 13, 14, and so on when you list all of them. Now, this one is asking you about probability. So for some reasons, people don't read anymore. They forget. I know we did it in this in Unit 3, but it's an easy question. You should be able to remember it. Okay, so the PE complement is 3. This one is asking about probability. This one is asking about raw data. Okay, so this is 3/4. Okay, suppose that E and F, let's go to number 7. E and F, I started from number 1. Let me keep on doing that. What do we have? Let's see what the time is. So we still have time, yeah? Okay, suppose that E and F are 2 events and that PE and F is equal to 0.1 and PE is 0.2. What is the conditional probability that of PE given PF given that E happened first? Okay, let's make sure we say this again. If you know how to define, I'm going to clean this out. Okay, so we want to make sure we define our conditional probability correctly. You want to make sure that you know the formula. That formula is very, very important. You know the formula for conditional probability. So the conditional probability formula says, if you're told to find the probability of F, the first one, given that E happened first, it is the same as the probability of F intersection E divided by the probability of the one that happened first. The probability of E intersection F intersection E, remember that this is an multiplication. And now let's go and find out what are we actually given. So we are given PE and F as 0.1. So we fit it in the formula. We are given the numerator. Okay. And then PE, we're also given the denominator 0.2. What is the conditional probability? So PF intersection E. All right. If I move the decimal point to the right, I have 1/2. Therefore, PF, given that E happened first, is 1/2 or 0.5. It's a type an integer or decimal, so that they don't want a fraction here. I hope you know what that this means. Type an integer means, or a decimal, means your answer should not be in fraction. So that's 0.5. Do you have any question so far? Do you have a question? You can ask a question whether you're online or in class. You can ask a question. Remember that final exam is due on the 30th. And everybody must take final exam. If you omit final exam, it's a standalone grade. It's a standalone grade, and it can also replace one back test grade. So that is not what you can miss. Doesn't matter how, even if you're averaging an A right now, you must take final exam. And I give you 3 attempts. I don't know what else I can do for you. I give you 3 attempts. I took final exam from this practice test I'm doing now. That's why I don't have to do all of them. I took practice the 13 questions in final exam from this practice test. The only thing is that when you pull up the final exam, it's not going to be exactly the same number. Okay, let's get into, let's do regression analysis. This is unit 2. And I know some people have forgotten unit 2. The data below represents commute times in minutes and scores on a well-being survey, complete parts A through D. Okay. Find the least square regression line treating the commute time X as the explanatory variable and the index score Y as the response variable. So if I draw an L graph in the first quadrant, is saying that X, the exploratory variable, and Y, the response variable. And so this is the, remember that this is the predicted. This is the given. This is the given. Okay, so I will now get my calculator without wasting time and do a scatter plot of that. So the first thing you want to do is do a scatter plot. I hope you have not forgotten how to do a scatter plot. So I'm getting a calculator and I will turn it on. I don't want this video to be too long, so let me stop it and then